Good morning. My name is Holly Farmer, and I am with AWS Elemental. If you're not aware, AWS Elemental was acquired by Amazon Web Services just over 2 years ago. And AWS Elemental combines deep video expertise with the power of the AWS cloud to make it easy and economical for video providers to scale and deploy their workflows and put most of their focus on providing compelling content. Speaking of compelling content, NASA is also a pioneer in the application of advanced media, including 4K ultra high definition video. In 2006, NASA achieved a broadcast industry milestone when the agency successfully produced the very first live high definition transmission from space. Then, on April 26th of this year at 10:30 a.m. Pacific time, NASA delivered the first ever live 4K stream from space to Earth for viewing on the big screen at NAB Show in Las Vegas, and to internet users globally on 4K UHD devices. This live feed from 250 miles above the Earth was produced in collaboration with the US Space Agency, AWS, AWS Elemental, and Red Digital Camera. NASA streamed the live 4K videos from space using 3 primary workflows based on AWS Elemental software and AWS services. The use of live 4K streamed video helps NASA to enhance its ability to observe, uncover, and adapt new knowledge of orbital and deep space. So in this morning's session, we'll take you behind the scenes to learn a little bit more about these 3 workflows and how you can use these technologies today to accelerate your own high-resolution video initiatives and infrastructures. So I'd like to take a moment to introduce our speakers. First, you're going to hear from Brian Kelly. Brian is the Commercial Element Manager for NASA. And prior to his current role, Brian was a Thermal Control Systems Flight Controller, sounds technical, for the International Space Station. Responsible for the heating and cooling of equipment on board ISS, he has supported 7 space shuttle missions throughout the ISS assembly and accumulated over 3,000 hours of real-time operations experience in mission control. In 2014, Brian became a research integration manager, where he helped researchers navigate requirements, processes, and testing needed to successfully fly and operate their experiments on ISS. It was in this role that he supported this year's efforts to execute the first live 4K broadcast from the International Space Station. Second, you'll hear from Josh Winstead, who is a technical marketing engineer with AWS Elemental. Josh is an Emmy Award-winning broadcast and streaming professional with over 11 years in the industry, spanning news, sports, and public programming. And he was the co-solutions architect and engineer in charge for this first live 4K broadcast from space with NASA. And then finally, you will hear from Justin Benjamin. Justin is the live stream technical program manager for AWS Events. Justin's primarily focused on providing live stream solutions for product launches at global AWS summits, AWS reInvent, and the AWS website. Justin was primarily responsible for extending our viewership of that live stream from space to viewers online around the globe. So now I'd like to introduce Brian.
All right, thank you, Holly, and thanks, everyone. First up, I'm just going to share with you a bit of history of media and video at NASA and how that's played a role throughout our history as well as into today with the 4K event that we did. So in short, NASA's everywhere. We have our fingers in everything. We have underwater laboratories that serve as analogs for deep space exploration. We've got humans aboard the International Space Station today. We have aircraft and drones that fly over hurricanes to help inform how those form and strengthen. And we've got a satellite that just flew past Pluto. We've got the Voyager spacecraft that launched over 40 years ago and to explore the outer planets and has left the solar system and is still operating and sending back data from interstellar space. We've got the Hubble Space Telescope that looks as far back into the universe as we can go to help tell us about our beginnings. Media has played an unbelievable part in this journey. A lot of the scientists in the papers, they use all the bits and data, the raw data coming from all these sensors to help inform and make decisions. But media, whether it's imagery or video, that's how we bring the world along with us. That's how we help share our story and everything that we learn with you. This is the first photo that Alan Shepard took aboard his Mercury spacecraft whenever he left Earth for the first time. We've had humans on the moon. We've driven vehicles and our moon buggies on the moon, and we've returned samples. We have a recreation by Cassini of the pale blue dot. Everything you see in that little pixel by that arrow that encapsulates every single human being that ever has lived. Even our rovers on Mars are using imagery to embrace and join the selfie culture of today. And in my baby, the International Space Station, we have astronauts on there today. Yesterday, we had our 17th anniversary of permanent human presence in space. If any of you have kids, if they're less than 17 years old, they've never lived a day in their life where there haven't been human beings in space. And that's really impressive. And we use this as a platform to look at long-term space exploration, to look at how we can do research in microgravity and help inform things for improving diseases, looking at how to improve and make it more efficient to launch rockets and everything that you can think of. And I know this is the Streaming Media West Conference, not the Still Media West Conference, so images are great, but let's show you a little bit of video. Hopefully that's playing. There we go. So Ed White took his first spacewalk, first American spacewalk back in the Gemini program, and we brought the world along with us. The Saturn V, the largest rocket ever built, lifts off from the Kennedy Space Center and takes Neil Armstrong and Buzz Aldrin to the surface of the moon.
It's one small step for man, one giant leap for mankind.
During the midst of the Cold War, American astronauts and Soviet cosmonauts met in space in peace. NASA flew its first space station, Skylab. The space shuttle lifted the Hubble Space Telescope to orbit and subsequently performed 2 missions back to Hubble to upgrade and repair it. And then the International Space Station, the most complex international endeavor ever performed in space. So I imagine most of anybody that watched the Apollo 11 moon landings, they were captivated by seeing Neil Armstrong come down that ladder. It wasn't that they were looking at their TV screen looking for a landing capture sensor to say, oh, guess what, we're here. No, they were waiting to see a person walk down those steps, to see a person hop around on the moon. It's that video and that media that captured the world and brought everyone along with us. Oop. There. And then back to the International Space Station. If you weren't aware, it is massive. It's the size of a football field, including both goalposts. It has about an acre of solar arrays. It weighs almost 1 million pounds, and it was built over a period of almost 15 years, using both Russian rockets and NASA space shuttles. It's an endeavor of 5 agencies spanning 15 countries, although we've done research with over 75 countries. Every single little piece you see there was a different mission and a different mission to assemble the space station. Everything that you see, the first time they were ever put together was in space. They were never actually assembled or touched each other on the ground. Everything had to work perfectly the first time. And it's become this unbelievable platform that has allowed us to continue to do science, whether that's biomedical and life researches, whether that's learning how the humans adapt to long duration exposure to space, radiation effects, and how to build more resilient hardware and satellites, to protein crystal growth, to learning how we can combat diseases using the ability to take gravity out of the equation. In 2006, we enabled the first live downlink from the ISS. And this was an amazing feat. This was showing the world that, NASA isn't stuck in the Stone Age, right? We can come forward with technology as you guys evolve and as you guys develop and bring all this technology to the forefront and to the future. We need to make sure that we can stay there with you. So then, last year we got to work on, and then this year execute, the first live 4K broadcast from space. When we did that first activity, the first HD activity, it took about 2 years to certify the hardware to get it into space. And that's because we have to make sure that it meets all the requirements for NASA. We're a government agency, we love requirements and processes. And so we have to test everything to make sure that it's gonna work. With this activity, we had to certify it in about 35 days. So we really learned hard. We worked the teams on AWS and Elemental and on the NASA side to really make this happen. So first you get the hardware. We have the encoder on the left and the camera. You have all this hardware, you test it, you make sure it works, you simulate it. At NASA we have a saying, test like you fly. So that's where we test everything in an environment as similar to space as we can get it. And then we had to ship it over to Japan where it launched to the International Space Station on their HTV cargo vehicle. And once the cargo vehicle got to space, we had to actually capture it with the Canadian robotic arm and berth it to the space station. And then once the cargo vehicle's on space station, the crew actually had to go get the encoder out of, a couple thousand pounds of cargo and install it on the space station. You can see here in the bottom right corner. And then we actually tested the signal coming down to mission control to make sure it worked. And lo and behold, it worked the first time. And then that told us we really got this. Despite rushing, 35 days to get it on orbit, we knew this thing was going to work. And in April, we held the first live 4K event at NAB show. And not only, it wasn't just a broadcast, this was a back and forth with the astronauts. And here we're going to show you a little bit of a sample from that event.
Who's excited? First live 4K transmission from space ever.
And the flashes are just us compressing 20 minutes down to about 2.5.
Yes, we're ready for the event.
What is the ISS position in orbit right now?
Well, we're just passing over Baja, California, and we're heading in an arc over North America. By the time we finish talking, we'll be over Central Africa.
Wow. Amazing, amazing. Now, of course, we're calling from the NAB show here in Las Vegas, where next generation broadcast and production technology comes to life. Are there any films about space that have truly inspired you?
Oh, for me, it was definitely The Right Stuff. As a test pilot who, Edwards was my second home. The start where he's like flying through the clouds and he's talking about there's a demon that lives on the mater. And then the plane crashes, it explodes, it goes to color. That's just so awesome. And then also Spaceballs, because we're basically flying at ludicrous speed right now.
Okay. What do live 4K and Ultra HD help you do on board the ISS in terms of scientific research that you couldn't do before?
4K and Ultra High Def actually make you feel like you're there. I mean, if you look really close, you can probably see into my pores right now. Granted, nobody wants to see there, but everybody wants to see the Earth from this vantage point. And probably the biggest impact that these technologies will have is bringing everyone else on the planet to see these amazing sights that we get to see every day and inspire them to push beyond just living on Earth.
And we're going to play ping pong. And a little food coloring added to that.
Peggy, Jack, I don't know if you can hear the oohs and ahs in the audience here, but it's tremendous. Congratulations on all your accomplishments, and we look forward to a lot of live 4K UHD from the space station for years to come. Thank you.
I remember when we upgraded from standard def to high def and how good it looked, and I can tell you that the amount of crispness and sharpness that you see in the upgrade from HD to 4K was unbelievable for me. It was so fun to be a part of that. Thanks for allowing me to share how NASA's done our history in video, and Josh and Justin here are going to tell you all the nitty-gritty details of how we got there. Thank you.
Morning, everyone. Thanks, Brian, for the perspective and the background. So now that you saw a little bit of what we did, we'll go into the architecture, the solution that we designed to make this happen. Like Holly mentioned, I'm a technical marketing engineer with AWS Elemental. I do a little bit of everything as far as solutions design, working with customers, but also demos as well. So this was a fun project to get pulled into and make happen. So some of the challenges that we faced looking at this project were, getting the encoder up there, assuring failovers and redundancies were in place, testing, a lot of testing, and then maintaining the quality and ensuring that we could get this 4K signal encoded properly so it maintains its quality, but also down through the 18 megabit pipeline. So what we had to do is take our standard data center appliance and shrink it down a lot, and make it compliant with Brian's rules. And so this is what we came up with, which was a much smaller version to accommodate all of the power, audio, and size restrictions in order to achieve this. So it's still running our GA software. Software on it's the exact same stuff that all of our customers use. It's just on a much more heavily modified box to accommodate the parameters that we had to meet. So as you know, working with 4K versus HD, we're moving a lot more pixels. And of course, doing this from space with the limited amount of connectivity presented some unique challenges. So we utilized HEVC compression for all of our backhaul. And then as we go into the architecture here, the HEVC UDP stream was utilized for transmission down to Johnson Space Center, where we combine the audio because the red camera doesn't have the ability to embed the audio in it, so we had to send that down on a separate path. So we combined the two at Johnson Space Center, re-encoded that, send HEVC UDP over to Las Vegas where production control was, decoded that, used it in the show, and produced a whole other live event on top of this, and then re-encoded that and delivered on AWS for that. So I'll be talking about everything from this far side to the right, and then Justin will be filling you in on the delivery side of this. So first, like we mentioned, ensuring that the encoder was going to work, and it did everything we needed it to do. A lot of testing and work on our end, on the ground, a lot of testing with Brian's team. And then the RedCam fed quad SDI into the encoder. And then, like I said, we utilized HEVC UDP transmission down to Johnson Space Center. On that 18 megabit link, we were pretty happy with how everything looked. It was a nearly flawless transmission. We saw zero artifacting, zero hiccups in that backhaul transmission. And then on the re-encode side at Johnson Space Center, same thing on the long distance haul because it went back to space, bounced off a satellite, and came to us in Las Vegas. So with all these different hops in there, obviously building redundancies and ensuring we're not going to degrade the quality of the video or mess it up was of high importance. And then on top of that, we had to send audio back to the space station. So audio was coming back through from Las Vegas to Johnson Space Center and going back to the astronauts so we could enable this two-way conversation. Once we were on site at Las Vegas, we had, like I said, a satellite transmission, which was IP satellite, to take that stream from Johnson and deliver it as our primary path. Then we had a backup path on a dedicated fiber circuit that was put in and achieved one day before the event. So we couldn't do a lot of testing before that. But we went ahead and got it working, and a couple hours before the event, our backup path was also good to go. So with that, up to this point, you're looking at about 10 to 11 seconds of delay, just because of the trip, the encode-decode process, and the overall delay that you're going to see in that. So what we had to do is ensure Sam Blackman, our CEO, who unfortunately passed away earlier this year, he did a great job moderating the event and just keeping it going, helping to fill in those 10 or 11 seconds to make it interesting and really brought it to life with the astronauts. So as you probably know, the usual production process, take in our remote feeds, utilize cameras on site, typical show production from that point on. And then we took our output from the switcher and audio and re-encoded everything for delivery to the audience who was outside the Las Vegas Convention Center. So here's a perspective of our production control behind the stage. Usually, it was pretty calm. It was, as far as live TV goes, it was pretty calm. We had 0 hiccups. Everything worked as expected and as designed. And we were able to fly through the show without issue. So it was a great relief and, of course, just a lot of fun. When things are working well and everyone's happy, it's a great time. So here's a perspective of the output encoding Abr stack that we did. Like I said, we did HEVC UDP as the backhaul to minimize delay and to ensure the delivery of the content as high of quality as possible. And then what we decided on the output side, though, for the audience not at the Las Vegas Convention Center was to use H.264 due to player compatibility. So that's a question I get a lot is, well, you were using HEVC here, why'd you do H.264? Well, player compatibility being the biggest reason why. We went with a bit of a modified Abr stack to accommodate a pretty wide range of devices and environments that these would be viewed in. We did a UHD and a full cinematic 4K variation on that. A lot of folks end up doing 2K and then a 4K step to make it a little bit more digestible on those players, but this is a step we took and had 0 issues with it, which was really nice. And then when the show started, for those of you who aren't familiar with our packaging product, Delta, provides real-time statistics so we can monitor and see how all this is running. We did all of our packaging in Elemental Cloud. We did ground encoders because of the 4K requirement at the time, and then we sent that to Delta package in the cloud. And as you can see, egress started ticking up pretty quickly out of the origin server once we were live. We maxed out at 1.5 gig out of our packagers, which was nice because being in the cloud already, everything scaled nicely, adjusted to that demand, and we had 0 hiccups in that. As you probably know from doing stuff on the ground, usually you're limited by your connectivity and bandwidth at the venue. By offloading my packaging to cloud, I was able to work around that without worry for crashing. So what we did from the ground to the Delta in the cloud is a 2-second chunked transfer, which then I repackaged and turned into a 4-second segment size stream out of that. So we were able to keep our bandwidth capped at about 50 megs leaving the Las Vegas Convention Center, and then allow that scalability to happen in the cloud per the demand. So from this point, I'll hand over to Justin because that's where our signal gets tossed to him.
Hey everyone, thanks for coming. Stream Media West can definitely use this audience to see how many space nerds show up to the conference, so thank you for joining us. So as Josh mentioned, all of that workflow that needed to take place to get the signal to us in the cloud, could argue maybe I had the slightly easier part, just with everything that had to go on with the NASA side, but it was also still really crucial that we had this component so we could increase the viewership of the event outside of just the Las Vegas Convention Center. So as Josh mentioned, we had our 2 HLS streams coming into the Delta origins there. This is our origin server working with the Amazon Elastic Load Balancer to help manage the networking. And then that would be sent over to CloudFront. In between that, we had Amazon Route 53. This is acting as our DNS and also with our routing policies. And what this allowed us to do is manage our failover scenario. So you see we have 2 different regions there, California and Oregon. So in an unlikely event that one of those regions was not available, we'd be able to really quickly manage that and fail over. And then from there, we're sending our output from the Delta in conjunction with our regional edge caches and CloudFront locations. That allowed us to bring this content much closer to our viewers and also offset some of that operational burden that would be placed on the origin servers. And then with CloudFront acting as our global content distribution network to get our content out to all of our viewers and their devices. And on the devices, people would watch our event on our website, which is live.abusevents.com. And with the 7-bit rates, people could watch that from a very mobile-friendly 280 all the way up to the 4K resolution. Yep.
So, as we moving through this project, as you probably know, designs change, they evolve, the demands tend to change as well. So being able to architect this in the cloud with Justin's team really gave us a lot of availability for that flexibility. When it comes to guessing your load size and what your viewership's going to do, that really is helpful in this regard because of the elasticity. And all of these documents, by the way, are online and available to check out if you want to take a closer look at it. We try to make this as repeatable as possible for anyone else who wants to do a similar workflow. So we make all this available to you if you'd like to take a look at it. If you want to watch the full event, we are on Amazon Prime Video. So feel free to take a look at that in full 4K. And then, just some of the highlights of working with the astronauts and working with Brian's team and the NASA broadcast team were really, it's really fun. Like I said, it's work, but it's fun work. And being able to push the boundaries, do new stuff, and really innovate and try new things is just a blast. Some of the positive review that we received from viewers, it was really nice to see the real-time feedback, so that way we could react to anything. Thankfully, my first time in 11 years, there were 0 negative feedback, which was a complete shock. We had 0 buffering instances, 0 loading issues. That ABR stack worked really well with the CloudFront delivery system. We're able to achieve a perfect linear viewing experience on these devices. So that's the overview. From this point, we will go into a little bit more of a deeper dive with some Q&As, and then we'll take some questions from the audience and go from there. In the meantime, I'm going to go back and put this diagram up so that way you can take a look at it a little bit more if you'd like while we're discussing it. So really the biggest thing is what we're learning from this. This is the first time we did a full 4K workflow and from end to end. And it was the first for NASA as well. So first I'm going to start with Brian. Brian, what was the biggest learning moment for your team in this?
I think certainly for me, I got to attend the NAB show, and I'm immersed in the ISS environment and the NASA environment every day, but during the event, when you heard all the oohs and ahs as the crew is floating around and doing stuff, it's easy for that to become commonplace at me. But when I heard that in the audience, it really reminded me just how important it is to continue, bringing the world along with us as we explore space, and how much everybody really loves that, and how video and imagery is key to harnessing that experience with them.
And Justin, this is the first 4K event that your event team pulled off. So what did you guys take away from this?
Yeah, for us, we had a very short runway for this event when we found out that we also wanted to provide the online experience. And our typical workflow for our summits and NABIS events is a 1080p workflow. So we had to do some of our own investigation and work on our side to see how we could make our current workflow compatible with the 4K stream. So it was a good learning experience, and I think it added value for everybody.
Great. So, Brian, what role do you think the HEVC codec, more increased encoding efficiency is how are they going to help NASA with your future projects?
Sure. So, typically, I'm not an RF engineer, but as you get further and further away from Earth, our ability to transmit data back and the bandwidth we have to transmit data back goes down quite a bit. What we have from in low Earth orbit on the ISS isn't nearly the bandwidth we get from, say, Mars. And so it's really important, especially if we want to continue to bring video, to these outer destinations, that we find ways to really efficiently encode it to take up as little of that bandwidth as possible.
And I know it was a quick but difficult process getting, certifying the encoder and getting the camera up there as well. Can you kind of run us through what that checklist was? Because I know that you and Tom Gilman and the engineering team at Elemental really went back and forth a lot fine-tuning this.
Right. So the ISS is really this unique environment. It's kind of a closed tin can in space, and our atmosphere is a little bit different. So we have different requirements on things like flammability and off-gassing of parts, namely plastics and stuff, because it's not just going to disperse in the atmosphere, right? It's going to stay there with the astronauts. So we have to be very careful of that. Our power systems and grounding works a little bit different in space since you're in this isolated tin can. So we have a lot of power requirements, and we need to make sure not only that the encoder is going to work, but that it's going to work safely in the environment that we have on board. And so we have all these details and requirements that are specific to working in space, and so that's what we needed to do to make sure this would work.
Okay. And Justin, going back to your team, you do TwitchCon, you do all these large events with a lot of viewers. How does your team kind of estimate what viewership would be and what to anticipate on the egress and delivery side?
Yeah, so for us, with any live events, I always just plan on catastrophic failure, every part of the system breaking. So we take that in mind when we're coming up with this workflow. Just if this piece goes out, how can we fail over, making sure we have hardware resiliency everywhere possible. So that's something we took into account. Initially, we were originally looking at doing like a 4K rendition and 1080p. And when we just thought about the viewing experience for the customer, we're like, well, it's kind of a huge jump for the segments to go from 1080p to 4K, and that doesn't really help our people that may be on a mobile device that doesn't have the bandwidth. So that's when we came up with the 7 bit rates to provide the entire experience. So.
Great. And then overall, how I mentioned it a little bit earlier, so we try to make all this available for everyone to take and create on your own. How repeatable is this project in your opinions?
So certainly on the ISS side, the way we worked it is we could go plug the encoder in, turn it on, and get the 4K signal down to mission control today. We could go do that on board. So that aspect, it's very repeatable. And then we just need, I think, set everything up with your teams.
Yeah, and same on the AWS side, very repeatable. All these services in use today, anyone can use them. So.
Great. Then I can say, at least from the, like I said, on the encoding and the operations side, since we have this ABR stack, we have this workflow created, it really is just a matter of flipping the switch, getting the equipment put in place, and turning this all back on. So, with the customer focus in there, that's really what we tried to strive for in this. We didn't want to do a one-off build that couldn't be repeated. We want to make sure this was something that could be taken, replicated, and customized for different needs. So with that, if anyone has any questions, we'll open it up to audience. We have about 5 minutes or so, or 10 minutes, sorry. Go ahead.
Is the AWS portion, did you have to create a cloud formation template for that?
Yeah.
So repeat the question.
Oh, yes. So you're asking if we had to create a CloudFront template, CloudFormation template for the distribution? We did, yeah. And you're wondering if it's available to use, or?
So not CloudFront. CloudFormation is a different AWS service that allows you to define a JSON template that describes your AWS infrastructure, so that you can make it repeatable and actually just you submit it to one API and the whole thing gets built.
Yep. Yep, we can provide that.
Yeah, so to elaborate a little bit more on that for you, that egress point, how the delta is going to change. So yeah, that CloudFormation template will exist, but there's obviously going to be some tweaking in there to adjust to your endpoint pool and then your caching needs as well. Thanks. Right here.
So Brian mentioned this is a repeatable process. How many small clients are using it?
So I know that some folks in NASA are working and looking at how we can embrace 4K in the future in live events. I don't have any information on something specific at this time, but I can certainly look into it for you.
Just a general question about the overall cost of this demo and how it was paid for.
So we don't have like a quantified number on it, but we worked with NASA, with NAB, and of course within the entire AWS organization to pull it together. Like I said, we don't have like a final number of sorts, but yeah. But if obviously you would need multiple encoders. You're going to need the satellite time. just, I know I don't want to rattle a number off and it'd be grossly inaccurate, but, you take into account your production cost, take into account your encoder needs. Like I said, we had redundant paths through everything, so 2 of everything to ensure that was going to work end to end in case there were any failures. But like I said, I don't want to take a stab and it be like just horribly inaccurate. Yeah, no problem. In the back.
What was the timeline, or anything was the deadline? When did you start? How big was your team to pull that off?
So the question was, when did we start this, and what was our timeline? So the planning started, about a year ago, or a year before the event, and then I guess the date. You probably fill in the date of when you guys started on the encoder certification.
Right, so I got my hands on the hardware in about October of last year, and we had about 5 weeks to do all the testing and certification of the hardware before we had to ship it to Japan in mid-November to support that space launch. I think it was in December or early January to actually get the hardware on board. So we were kind of running for the gate of being able to make our launch vehicle.
And I started production planning in February for this. So that's when we all started, when Justin's team was brought in, we sat down and started
Mid-January.
Or January for you guys. On the production side of it, we were in about February where we really started digging down into this. Obviously, we started a little bit earlier on like a general plan, but when we got to the point of this is how many cameras we're going to need, this is where our satellite hops are going to be, this is where we're going to place encoders, was really February. We pulled it together in that February to April timeframe.
And fairly small, to enter on the team size, fairly small teams to work on this on our end too. So.
Any other questions? Yeah.
Have you done another stream since, or has that encoder just been shut off?
The question was, have we done another stream since? At the moment, we have not done, I think, any additional 4K streams yet.
So, one of the other things, that we wanted to talk about a little bit was, how do you see, Brian, how do you see NASA, I guess, evolving with these tools? I know we touched a little bit on that, but, like in future projects, what do you guys have planned with the 4K delivery or any other projects in that?
So, back in 2006 when we did the first live HD downlink, that was kind of our test bed, our proof of concept. Can we make this happen? And a couple of years after that, we actually launched a payload externally that's out on the Columbus module that now live streams HD video from space 24/7 that you can go on the internet and see at any given time. And so I like to think that, this event was, again, our proof of concept. That was our test bed to show that we can do it. And my hope is that now we can evolve to make it more commonplace and more standard to have 4K video come down from space station all the time, as well as, how you can use that in research and experiments, whether it's our combustion experiments or fluid that you can use now, the aspects of higher video to help.
Well, speaking resolutions, a little bit of a tangent, but speaking of like the use of 4K in the experiments, it was interesting for those of you who haven't seen it. The astronauts went through some very basic experiments to just show what they're working on and how they look at stuff. And the quality, the detail from that picture, being able to see all these little fine points in this experiment were pretty exciting. Is that like common feedback that you get, or is this just like a one-off thing with 4K delivery that?
Right, so there are some really detailed experiments that we have on board that actually rely quite heavily on video. We have a combustion integration rack, which actually does small little explosions in space, and we use video on that to really see how how fire and flames work in microgravity, and that can help inform systems and propulsion in the future. So if we could have a video, a camera 4K that's giving us even more greater resolution, we can use that to have greater insights into all of this.
Cool. And I know we only have a few more minutes left, so I just want to make sure, does anyone have any more questions? No? Okay. So we'll close with this. Justin, what was your favorite moment of this whole project?
Let's see, I think one of my favorite moments, at least for me, that I got really excited about. So we did a bunch of offsite testing, each piece of the workflow, gradually building up to doing an end-to-end workflow test where we'd finally get the live feed from the ISS, where a lot of times for our tests we would use recorded footage so that we could do tests on our own without requiring the ISS live feed. And so I just remember I was in San Francisco. I had in our lab set up with monitors, and I was waiting for the first frame to come on for the first transmission of the live aspect. And I just remember the frame comes on, and Dr. Peggy Watson is holding up an iPad, and we're doing an audio sync delay test. And so she's holding the iPad, and the counter's going, and she has to go back and get the microphone. And I'm just like, okay, like, you know, I guess this is live footage. And then she just lets go of the iPad to go back and get the microphone, and it's just floating there as the stopwatch is going by. I'm just like, wow, okay, this is really happening. This is awesome. So that's probably one of my favorites.
And for you, Brian?
For me, it was all these milestone achievements, right? I remember handing over the hardware to our cargo packers, you know, after rushing, you know, 24/7 for 5 weeks to get this thing done, handing it over and saying it's in their hands now, and then watching it actually lift off, you know, and fly into space, and then actually seeing the pictures of it installed, and then testing it in mission control, and actually seeing the video come down, and then going to NAB and just watching everybody be captivated when the crew was actually executing the event. So there are all these little milestone things that really just brought it all home for me.
Yeah, I'd say for me there are two different instances. That initial test where we're talking through the Johnson Space Center back to the crew, Commander Whitson and the other astronauts that were up there. Yeah, so it's playing radio. You know, it's like, hey, tell them that we need to do this, and it was amazing, that feeling of working with, you know, these amazing professionals and doing audio sync testing, something as simple as sync testing. So that was, like Justin was saying, that was pretty amazing. And then, of course, that event, that first 11 seconds when Sam, you know, tossed to them and we went to boxes, and you know, they're waiting for us to get started, and you know, everyone was on pins and needles as Sam said, "Hey, are we ready to go?" And then it's silence, it's silence, it's silence, and then, "Yeah, we're good." And then it's just the room erupted. So that feeling of accomplishment and to see the joy and just the excitement in the room. I've never seen that outside of sports before, and it was pretty amazing. So with that, thank you guys for joining us today. Thank all of you for coming to the session. I hope this was helpful. Feel free to reach out to, you have our contact information in the paperwork there. If you have questions, need some assistance, feel free to reach out. We're happy to help. So thank you.